got a crazy amount of stuff to cover today, folks, so no screwing around. Looking at the sun, 193 angstroms. I have about 94 tabs opened on my device, and we're going to make at least 2 videos, possibly 3 throughout the day today. So here's the 193 angstrom view. We see coronal holes in the south, no sunspots. A couple weak active regions here north of the equator. Here's a view of those coronal hole systems. And one small area of activity popping up there, likely another cycle 25 plage. Here's the view in 304 angstroms of that same area, complete with date stamps. And one little active region rising there. We'll analyze the magnetics momentarily. There's the full view. And that's 9 hours on this day, January 22nd, 2020. I just wanted to let our viewers know that we've listed the index of images here, and that is from Space Weather Prediction Center at NOAA. And let's get into some data. Gauss proton flux is a new thing that we're going to start picking up. Now that the solar activity is picking up too, expect to see some protons. Speaking of protons, let's cover cosmic rays real quick. We saw an uptick over the past 3 days at the Apatity neutron monitor. Barentsburg hasn't been sending data. Smaller uptick there. Let's look at a few more monitors here, and we always leave links to the network of cosmic rays stations below the video in the description. So if you want to monitor cosmic rays yourself, please feel free. Here's the Athens, Greece neutron monitor. Small uptick there in the past couple days also. Next we'll go to Mexico City. And there is the Mexico City Cosmic Ray Observatory. Small uptick in the past couple days there. It never got as high as it did on January 4th. Next we'll check out Moscow, which typically has a pretty wild range. And back to not sending data there for a few days. Get back on at Moscow, and here's Oulu. Please don't track me down, Vladimir Putin, for complaining about the Moscow neutron monitor. And there's an uptick at Oulu as well. So small uptick in cosmic rays there across the board, for the most part. And there's DOMC Antarctica, DOMB Antarctica not sending data. Again, we always leave links to the network of cosmic ray stations site, so you can monitor them yourself. Let's get back to solar data. Direct solar data, that is. And we don't see any kind of flaring in the GOES X-ray flux. 10.7 centimeter radial flux still at 71 as we hover near solar minimum conditions and see a weak solar wind, which has enhanced a little bit since yesterday. Got the KP index up to 3 at about 8 p.m. Universal Time yesterday, and then it popped back down to 1. So we'll be keeping an eye on the solar wind data to make any forecasts on that. There's the ACE data, and we saw the solar wind density did pop up above 10 there, causing the scale to expand, and an increase in the solar wind speed at the same time as the density. And there's the Discover data. We did see the BTBZ shifted all around. It got all the way to -9 in the BZ component there, and a very strong field at the same time. So the field strength, the BT was all the way up to 9, and the BZ was at -9. So very strong and negative oriented fields. We still see the strong fields there in the upper pane, the BT, the black line, and the BZ dropping back down into major negative territory again. Phi angle currently around 320 degrees. Solar wind density down to 4.74 protons per cubic centimeter. Solar wind speed up from yesterday at 358 kilometers a second. Next, we'll look at the geospace magnetosphere movies, and we see a slightly higher induced pressure here as a result of a bunch of protons and a slight uptick in the solar wind speed since yesterday. Not such a weak magnetosphere. And we do see some induced currents on the ground. We'll show you next. Anyway, there's 4 hours of data of magnetohydrodynamic pressure. Pretty weak coronal hole wind stream there. And there's the magnetic perturbations, and we see significant perturbations, including a magnetic pulse coming out of, or you could say going into, Hawaii. You'll see it right about there, around 9:15 UT. That area centered on Hawaii. And let's just let that play through again. Since we're living through a magnetic excursion, we've got two North Poles, one over northern Canada, one over Siberia, and the South Pole creeping into the southern Indian Ocean, somewhere southwest of Australia is the real location of the geomagnetic South Pole. And there's a second run on the 4 hours of data, courtesy University of Michigan. Geospace Delta B, ground magnetic perturbations. There are the relativistic electron flux and pretty low electron density out there in the Van Allen belts. And there's the GOES electron flux, quite low levels here. And we're expecting this to uptick in the next 48 hours as a result of the incoming protons. Next, we'll look at the ionosphere, and there you've got 6 hours of ionosphere data. We see continued measurement anomalies apparently occurring there on the prime meridian in the southern hemisphere, and a very discharged ionosphere. Some anomalies in the South Pacific, off the west coast of South America, where it's charging up at nighttime. So anomalous ionosphere once again, folks, and it looks like it's charging back to a more normal level here at the end of the video. There's the latest image, 9:15 UT. That's the current state of affairs for the ionosphere. And again, you see that anomaly in the South Pacific there around the 30 latitude by 135 longitude area. GOES magnetometers are looking pretty spiky here, and that's largely a result of the incoming coronal hole wind stream. Expecting that to smooth out as the coronal hole wind stream calms down. It's looking like a pretty weak wind stream. And let's look at the Gong 2 data here real quick. Looking at the top view, ecliptic plane field plot. As the Earth is solidly in the South Pole oriented portion of the current sheet, shown here in red. Looks like there's some activity on the far side of the sun, but nothing to write home about. And let's move on to some more stuff. And it's the earthquake rundown. We don't see any 6 magnitude quakes in the past day. Let's scroll up the list here. A deep quake in Mexico struck at 9:49 yesterday morning in New Mexico. That's universal time, by the way. 4.8 magnitude, 125 kilometers depth. There's a deep quake in Indonesia. 4.6 magnitude and 156.2 kilometers depth. Here's a shallow quake at Hawaii, and let's go take a look at that one. And once again, we see a very high quake, the opposite of a deep quake, folks. This one is at over 1,000 meters directly under Mauna Loa. Not precisely under the main caldera there, but under a sub-caldera. And you can see how high the altitude of that was. It's at negative 1.8 kilometers depth, meaning it's 1,800 meters above sea level. So that's clearly magmatic motion there, folks. Some magmatic activity below Mauna Loa, once again documented. And let's continue scrolling up the list. If I can click, there we go. And we'll see what else has struck. A couple quakes hit New Zealand there at a 4.9 and a 5.0 magnitude. Looks like we just updated. There's a 5.5 at Fiji. I believe that is the largest of the past 24 hours. That one coming in at 57 minutes after 0 hour, folks, just before 1 a.m. Universal Time. Deep quake strikes Indonesia once again, 4.5 magnitude, 129 kilometers depth. And let's move on to greener pastures. Now we're looking at Shishaldin. That's not Shishaldin. That's Kluchevskoy. Kluchevskoy volcano. Taking a look at that real quick. And I just wanted to show you the cam. There is a webcam. You bring it back a little bit into daylight, you'll see this thing erupting. And there you see some eruptive behavior from Kluchevskoy. Not Shishaldin, folks. Shishaldin is in the Aleutian Islands. It's Kluchevskoy. We saw an uptick there. Let's zoom out and look at the pressure maps as we start looking at the meteorological data. And we'll just let this advance. This is the GFS model of pressure cells. You see the high pressure in a dark red, low pressure in white to light blue. And we'll just let that advance until about 12 Universal Time. That's 12 noon Greenwich Mean Time tomorrow. There's where we are expecting pressure cells to be at that time. And here's the volcano list. Again, Kluchevskoy erupting, producing a 20,000 foot ash plume as it explodes. Mount Aso, flight level 5,000 there. Tall, unknown whether or not that's emitting any ash. Dacono exploding, 6,000 foot plume there. Popocatépetl, some new emissions there. Fuego back on the list, although volcanic ash not seen. Sangay, new emissions there. And Revenador exploding, flight level 16,000. Please do not fly your John Denver style ultralight over Revenador's caldera. Arctic sea ice can't bounce back, although it does every year. We've left links to this phys.org article where some folks are studying clams and counting clam growth rings, and they're very worried about the way their climate models suggest that the ice is going to suddenly melt. And they're going to wring their hands and be very, very concerned about sea ice. When there's lots of sea ice loss, some of it drifts southward, releasing fresh water, messing with the Atlantic meridional overturning circulation, and all kinds of other positive feedback things that don't seem to actually happen, except in their useless climate models, which prompt me to say garbage in, garbage out. For all you folks who've written computer code, you know what garbage in, garbage out means. It means if you put a bunch of crappy code, your computer's going to do all the math correctly. And guess what's going to happen? You're going to end up with garbage results. Because if your inputs are garbage and you don't understand the way the climate works in the first place, you shouldn't build a computer model about the climate. It's a screw up. And it's a waste of taxpayer dollars largely. And here's where the lightning is striking right now. Courtesy lightningmaps.org. We don't see any lightning strikes happening in the U.S. Check out lightningmaps.org if you hear thunder, perhaps. It could save your bacon. And let's move on to null school as we look at these extreme meridional jet stream flows. The northern hemisphere jet stream is so broken up now that it's barely coherent as a jet stream. As you can see, it's all over the place. It's doubled up, tripled up, and quadrupled up. And we have some of it flowing the wrong direction over Central South America still to this day. Been watching that for days. Here's the eastern world's jet streams, looking a little more coherent, although indeed also doubled up in the northern hemisphere. And we see a 180-degree turn here south of Australia. Check it out. You're going to hear stories about how it's unseasonably cold over here and unseasonably warm in Antarctica, as warm air gets pulled into Antarctica right after cold air gets pulled into Australia. So this is what's controlling your weather patterns, folks. It's not you. It's not CO2. It's the sun, which is why we study it so in depth. Here's a value-added service for you. It's the U.S. Doppler radar animation. And we see some heavy snow falling over eastern Oklahoma there, probably wet snow, as some dry air is pushing its way across. This is going to be taking its time moving from west to east, it looks like. And some severe ice there coming down in northern Iowa. Shout out Aubrey and Iowan viewers. Let's just do a close-up of Oklahoma real quick. And I must have clicked on the wrong station there, folks. Again. Anyway, this data brought to you by Weather Underground, named after terrorists. Next, we'll look at the U.S. water vapor map. And there you have the data from the U.S. water vapor map. Looks like a strong low pressure system in the Atlantic Ocean off the coast of Florida. And let's zoom in on this line of dry air over northern Oklahoma. The site of our weather pornography section for the day, where we encourage our viewers to understand the way atmospheric physics really works, as opposed to the way countless science articles will tell you that it works. Anyway, you can see that dry air acting as a barrier there, creating a massive pressure gradient between that atmospheric river headwaters. And looking like some fantastic conditions for odd cloud formations in south central Colorado. Go out and get some photos of those lenticular clouds, folks. They're pretty rare. And if you enjoy the content, please press like and subscribe on YouTube. We've got hundreds and hundreds of space weather videos, cosmology segments, and other stuff. Thanks to our patrons. If you're not a patron yet, please consider becoming one. The main source of funding for our operation. We are expanding vastly in 2020, so get in on the ground level. Join the SMASH team, and thanks SMASH team for joining the live premiere or wherever you watched it, whether you watched it on BitChute or on Minds or wherever you watched it. Thanks for tuning in. Check out some bonus segments. Have you been to smashomash.org and checked out the forums, which are linked right on the homepage, right there? Click here for the newly unveiled smAsho forum. Going to talk about people losing their minds. And here's an article linking aluminum exposure to Alzheimer's. Now, we're not exactly sure if the aluminum is causing it or if it's correlated. Let me read this paragraph. Compelling localization of aluminum with central player in AD, that's Alzheimer's disease, amyloid plaques, folks. Amyloid beta strengthens the link of aluminum to the pathogenesis of Alzheimer's disease, commented George Perry, PhD professor of biology. One could envisage increased amyloid beta brain tissue as a response to high levels of aluminum content, or that aluminum fosters the accumulation of amyloid beta. Either way, the new research confirms my resolve that within the normal lifespan of humans, there would not be any Alzheimer's if there were no aluminum in the brain tissue. No aluminum, no Alzheimer's. And this is a thing that I've understood since the mid-90s when I took a psychology class. And I don't know if you're aware, I was a psych major. I took 83% of the core classes for a Bachelor of Science in psychology. However, I did not continue to get the degree because, well, let's just say I saw the writing on the wall of science nonsense in college already back in the mid-90s. So check out smashomash.com/forum if you haven't yet. Nearly up to 100 members already. It's amazing. And let's talk about somebody else who lost his mind. 19-year-old murder suspect from San Antonio, Kieran Christopher Williams. Guess what he did when he got arrested? For murder, by the way. He tried to pump his Instagram page. He's an up-and-coming artist, and we wish him all the best on producing wonderful, brilliant music and writing, or whatever he's arting, whatever art he's producing from his prison cell, which we hope he spends a long time in as he goes around shooting people because they bump into him in bars. What a dork. He's lucky nobody shot back, as he did it in Texas. Pennsylvania woman drives into oncoming traffic to test her faith. This one printed yesterday. Nayeda Riley, 51, told officers that she was driving around for a few hours waiting for a calling from God. As she saw another car on the other side of the road, she decided to test her faith by driving through the vehicle. Well, She ended up getting charged with aggravated assault, simple assault, reckless endangerment, and harassment, along with several other traffic charges. A judge initially set her bail at $50,000, but it was later revoked as she was deemed a danger to the community. Told you people are losing their minds, folks. And were you aware that North Korea has closed its borders during this Lunar New Year travel time in the Far East? Well, the China virus toll has risen as pandemic fears grow. 9 confirmed deaths from coronavirus in China and 440 confirmed cases. Over 1,400 folks being watched. Actually, it's 2,197 now who came in contact with infected people. And we're interested to know if this is the same thing we covered on, I believe it was Saturday, as there was an apparent norovirus outbreak at Yosemite National Park. So is this possible that it was already in the U.S. over the weekend? Gestation period is super important with disease outbreaks, folks, as if you have a gestation period before you show symptoms of 10 days, it's much easier to spread a disease than if you get gestation period before symptoms present of 1 day, for instance, as you could travel halfway around the world, not know that you have anything to do with the virus. Those articles all listed below the video. And let's look at the local yellow dwarf here in intensitygram, just to show you that we got 0 sunspots. I'm going to show you the colorized magnetogram as well. That's the latest image. We just hit refresh. Small active region down here is the place to watch. Let me stop scrolling. This area right here, folks, right in there, that's the area to watch throughout the day for possible cycle 25 sunspot forming. Every place else, those other areas of magnetic organization are just plages. And we have, once again, we see plages from both cycle 24 and 25 on the solar disk. And let's look at the 335 angstroms view for a change here. This is a 48-hour movie of the local yellow dwarf. Again, the region to watch is this new active region right down here. It just kind of popped up. That's the thing to keep an eye on throughout the day. And when I say eye on, the pun is intentional. Anyway, look for at least 1 more video, possibly 2, coming out throughout the day today, folks. Thanks for tuning in. Remember, stare at the sun, don't drink, and if you drink, don't drive. And since it'll never be now again, may that solar wind be at your back and that atherosclerosis absent from your veins.